Welcome to SciSpectrum Lab Essentials, your source for equipment, instrument, and consumables.
Today, we're going to pull back the curtain on that crucial first step. All right, so to really get this, we have to start with the very first hurdle every single pill has to clear. It all comes down to some pretty basic physics and biology, but if you get it wrong, well, that medicine could be completely useless.
I mean, think about it. You take a pill, maybe with a sip of water, and you just trust that it's going to do its thing. We all do it, right? But how does that process even begin? It's not magic. It's a very precise physical event that has to go perfectly right from the get-go.
Well, that process has a name: disintegration. See, before the medicine can get into your system to do its job, the pill itself has to break apart into much smaller pieces. If it doesn't break down or it does it way too slowly, you're just not getting the dose you need. It's the first step, and you could say it's the most important step in the whole shebang.
And listen, this isn't just a friendly suggestion, it's a hard and fast rule. All around the world, there are these official rule books for medicine called pharmacopoeias, like the USP in the US, the BP in Britain, and the IP in India. They set very specific time limits for how fast a pill has to disintegrate. If it fails the test, it can't be sold, period.
Okay, so if this is so critical, how in the world do drug companies make sure every single batch of pills meets these standards? They don't guess, they test, and for that, they need a very specific piece of gear. And here it is. This is a digital tablet disintegration apparatus. Its whole job is to basically pretend it's a human stomach and measure with total precision if a pill breaks down exactly how and when it's supposed to.
Now, in a modern lab, it's not enough to just be accurate. You've also got to be fast and efficient. So let's look at one of the biggest advantages of a machine like this.
The magic number here, it's 2. Just the number 2. And that one little digit represents a massive leap in how much work a lab can get done, all thanks to something called a twin basket system.
So here's what that actually looks like. A standard machine can test one batch, so that's 6 tablets at a time. But this model, with its 2 baskets, tests 2 batches, a total of 12 tablets at the exact same time. It literally doubles the lab's testing capacity in one go.
I mean, just imagine you're in a busy quality control lab, trying to get through thousands of tablets a day. This is an absolute game changer. Doubling your output with one machine means safe medicine gets to people faster. It's a huge win for productivity.
Okay, but speed is totally useless if you're not accurate, right? In the world of pharma testing, precision isn't just important. It's everything. Let's see what makes this machine so darn reliable. So the secret sauce here is its digital brain. A microprocessor is running the whole show, controlling every little variable. This means every single test is identical, repeatable, and pretty much free from any human error. It's that automation that gives you rock-solid results you can count on.
Take the movement, for instance. The baskets bob up and down at a super steady rate of 30 strokes per minute. Not 29, not 31, 30. And that's exactly what those official medical rulebooks demand, perfectly mimicking the gentle environment inside our bodies.
And temperature? Oh yeah, that's just as critical. The machine keeps the water at the right temperature with an accuracy of plus or minus just half a degree Celsius. That level of precision ensures the test is a perfect simulation of body temperature, which is another one of those non-negotiable global standards.
So for the actual person running the test, the lab tech, the process is honestly beautifully simple. They just punch in the time and temperature on the keypad, hit start, and the machine takes over. And when it's done, an alarm goes off. It's automation designed for pure accuracy.
All right, so we've seen how it works, but let's pull back for a second and talk about who is actually using this thing day in and day out. Where does it fit in the bigger picture?
You know, the source material actually calls this a cornerstone instrument for quality control, and that's no exaggeration. It's really a foundational piece of the puzzle that holds up the entire quality assurance process. And you see it everywhere. It's a workhorse on the factory floor for quality control. In R&D labs, scientists use it to create and perfect new medicines. For quality assurance folks, it's the final gatekeeper. And it's even used in pharmacy colleges to train the next generation of scientists.